Let's do a quick overview on the conversation design and where the voice industry is today. You can find assistants in smartphones, in cars, or household devices, and they are everywhere. But what exactly is a voice assistant? In short, it's a digital assistant powered by AI that uses voice recognition, language processing algorithms, and speech synthesis algorithms to listen to voice commands to fulfill the user's requests. Examples of popular voice assistants today would be Amazon's Alexa, Google Home, or Apple's Siri. Voice technology has come a long way, but there's a shift towards creating a multimodal user experience that makes it easy for anyone to access the power of voice. Multimodal interfaces leverage several modalities, like voice and touch, which enables users to interact with the app in whichever way they prefer. So, what does this look like? First, the voice assistant must be built directly into the application and work on any device. It needs to be context-aware by understanding your application, its workflows, its language and terms, all while being in sync with the app's visuals. Lastly, it should allow you to craft your own custom voice commands to interact with the app. The Dream Voice Assistant is actually a multimodal user experience that combines voice technology with the app's existing user interface. This is exactly what we'll teach you to build. Let's talk about how Alan works. With your Alan account, you can take advantage of the Alan AI platform, complete with the out-of-the-box AI experience that includes access to AI libraries, components, and tools needed to voice-enable your app. Create your Alan Studio account now by going to studio.alan.app/register. The platform itself has three components. First, Alan Studio, Alan's web-based IDE, where you'll create dialogue for your voice assistant. Second, Alan's client SDKs will help you integrate the Alan voice assistant into your app. This will add the Alan button to your app and allow users to interact with it through voice. And finally, the Alan Cloud, the cloud-based environment to host and run your voice solutions. Think of the Alan Cloud as the brain on which your voice assistant relies for AI. This is where Alan performs all voice processing tasks that empowers your voice assistant to be smart and effective, including automatically training itself on massive amounts of data. With other AI tools, developers need to provide data sets and train the model themselves. But with Alan AI, you don't have to do that. It also creates and dynamically updates the domain language model for your app, meaning your voice assistant automatically updates and understands your app's unique terminology. And it's built to detect speech recognition errors, like mispronouncing or misspeaking, and can work in noisy environments. Alan's architecture is serverless, and as part of the Alan service, we also provide you with the upkeep services, including infrastructure setup and maintenance for your voice projects. Alan allocates separate virtual machines to run voice scripts, so your data is always isolated. It provides additional resources and redistributes workloads if your number of users grows. Alan can scale automatically, being able to support deployments with millions of users. And it also has top-notch cybersecurity, since Alan encrypts all data, both in transit and at rest. At any point, you have an option to move your voice deployment to your local site. Feel free to explore Alan's documentation on our website at alan.app. Today, we'll tell you more about Alan Studio and helpful resources. In the last video, you created your free Alan AI account. Let's talk more about Alan Studio, since this is where you'll probably spend most of your time. Here, you'll create voice scripts in JavaScript, which are the dialogues for your voice assistants. We give you access to our example projects so you can get a general idea of how your script can be arranged and laid out. Then, you can test your project and use our debugging tools to clean up any inconsistencies. After, review the Alan logs and analytics to iterate and understand what new voice features to add. Outside of Alan Studio, we also offer Alan Playground. After creating a project in Alan Studio, you can use the Alan Playground as a sandbox environment to test out your voice assistant as if it's already running in a web or mobile app. Alan Playground is available both on web and mobile. To use it, all you have to do is click into your project in Alan Studio. Then select Playground in the top right-hand corner. For web, click the microphone icon here and test your project. To use it in iOS and Android, you'll need to install the Allen Playground app on your device, then scan the QR code to begin testing. Throughout your voice assistant journey, we've created documentation to help you learn about coding concepts used by Allen, integration specifics, and more. Follow our blog and YouTube channel for more use cases and examples of voice user experience. Before we start talking about Allen's script concepts, let's go over the app we'll be working with throughout this course. Our food app is a simple web page where users can order snacks and drinks. Gradually, we'll build it from a simple web page to a multimodal application where users leverage two input modes of interaction, voice as well as touch and type. For the best multimodal user experience, the voice activities in the app will be synchronized with visuals, and vice versa. The touch and type actions will be supported with voice. Let me show you what I mean.
Hey, this is Alan, the voice assistant for a coffee ordering app. Start by saying, "What coffee do you have?"
What coffee do you have?
We have cappuccino, latte, americano. What would you like to order?
I'd like a latte, please.
Sure. Please choose a dessert. We offer cheesecake, brownie, apple pie.
I want an apple pie.
Your apple pie is added. Please provide your name.
My name is Jane Smith.
Thank you, Jane Smith. And what is your address?
My address is 1275 Main Street.
Thank you. We will deliver your order to 1275 Main Street. Any comments?
Please make my coffee with soy milk.
Thank you. We'll take a note. You have ordered latte and apple pie. Your comment is, "Please make my coffee with soy milk." Is your order correct?
Yep, looks good. And here's how the same things can be done with touch and type.
Thank you for submitting your order. Your order is cappuccino and cheesecake for Jane Smith, delivering to 1275 Main Street. Your comments: "Please no sugar in my coffee." Your order will be delivered in 10 minutes or less.
Each lesson and its following task are targeted at a separate piece of functionality needed for the voice assistant design. First, watch the video lesson, play with the code shown in it, and then perform the task following the lesson. We recommend that you try performing all tasks on your own first, but if you get stuck, you can have a look at the code example provided for every task. After you take a short quiz, you can move on to part 2 and start designing your first voice assistant. Welcome to part 2. We'll start building our first project today and kick it off by covering voice scripts. Log into Allen Studio and select Create Voice Assistant. Then choose Fluttershy. The example that we're looking at together is a voice assistant for a shopping app. Later on, you'll create your own voice project. Allen lets you create an unlimited number of voice projects, which will be handy for you after you've completed the course. Back to the Flutter example. When you create a project, Allen automatically adds a voice script for it. A voice script is a dialogue scenario for your voice assistant. It should contain all possible voice commands that your users can give and describes what actions your voice assistant must execute in response to these commands. We'll dive deeper into voice commands in the next video. Your voice project can have more than one voice script. Multiple scripts let you organize your voice assistant logic. As you can see, all questions for the voice assistant are in one script, data is stored in another script, and the logic is provided in the third script. Now we'll have you click on the back button in the top left-hand corner on the main page. Select Create Voice Assistant and name it My Voice Assistant. In our next video, we'll start adding voice commands to it. Let's cover voice commands and how you can define them in your voice script. A voice command is how users interact with a voice assistant. The voice command triggers an action for the voice assistant to take. It can be as simple as answering a question or executing a task. In the script, you can see that the first command is hello world. To define the command, we are using the intent function, which takes two parameters. First, a string with the phrase that must invoke this command, followed by the arrow function with Alan's response. In this case, Alan answers with text, but it can perform more complex actions and functions. Let's test it in the debugging chat on the right-hand side. You can type it or click the microphone icon and say, "Hello world."
Hi there.
When you say the phrase provided in the command, Alan replies with the text you have specified here. Don't forget to turn off the microphone by clicking the icon again. Now let's take a look at the special object, or the PI. This lets you call Alan-specific methods and access Alan's predefined objects. In our case, we're using it to call the play function. Play is the most used response function and allows both responding back and sending commands to the client app. Another function you'll encounter is reply, and only plays a specific text to the user. Alan's responses can be short, as in this example, or long and take several sentences. You can put a long response in the function like this. Or split it and add several response functions to the same intent. In our app, we will allow users to order food with voice. Let's add several commands to start the dialogue with our assistant. The first one will allow us to ask about the snacks and drinks offered. The second one can be used to get coffee. The third will allow us to get a dessert. You'll get more familiar with command functions in our documentation. Next, we'll look at patterns and alternatives. Let's talk about patterns and alternatives in voice commands. In Alan voice scripts, the phrase that invokes our command and the phrase with which Alan replies is called a pattern. The command in our script is currently rigid because the voice assistant will reply to you only if you say this exact phrase. When you communicate verbally with other people, you can say the same thing in different ways. For example, to get a coffee, you can use variants of the phrase like, "One coffee, please," or "I want a coffee." Let's make your voice assistant more human-like by providing multiple variants that invoke the command. We'll specify all possible phrases as the first parameter in the intent function and separate them with a comma. You can do the same now in your own project or later while you complete the task following this video. Now, your voice assistant will respond to any of these phrases. We can also use alternatives, which are the parts of the phrase that may differ. For example, you can say, "I want a coffee," or "I need a coffee." To define alternatives, we'll separate them with the vertical bar and enclose them in brackets. So in the typed example, we'll put intent, "I want, need a coffee." Some parts of the command may be optional. For example, in the phrase, "One coffee, please," a user might not say please. In cases like this, we can use optional alternatives. To make a word or a part of the phrase optional, we need to enclose it in brackets and add another vertical bar at the end of it. For example, "One coffee, please," we'll add the vertical bar after please. Now our command can be invoked by a mix of these phrases. Add some flair to your voice assistant and train it to respond in different ways. List all variants of answers separated with commas. This will be the second parameter of that intent. Now, when this command is invoked, the voice assistant will pick one phrase from the list at random and play it. As a sneak peek for our business logic and best practices in defining commands video, you will learn how to prepare a list of phrases for advanced scenarios. Now that you've mastered patterns, in our next video, we'll cover slots. Today, we're talking about Alan script basics and taking a closer look at slots. Users instruct the voice assistant on what to do. But to create a great workflow, it's also important to identify and retrieve pieces of information from the user's input. This is what slots are used for. For example, In a coffee ordering app, the voice assistant needs to know what coffee the user wants, like latte, cappuccino, americano, what dessert is chosen, and the user's name and address to deliver the order. In Alan, you can use two types of slots to pick out important facts from the user's interactions. First, user-defined slots are customized values for any concept, for example, coffee and dessert types. The second are predefined slots used to capture values of a standard type, like time, date, or location. Let's start with user-defined slots. First, we'll get back to our app. Here, we need to know the user's coffee and dessert choice. We'll define all possible values for it by using the $ followed by brackets. In brackets, we'll define the slot name and list the values for the slot. If we want to capture a value of a standard type, for example, date, time, number, name, or location, we can also use predefined slots. Because predefined slots are universally known, all you need to do is specify the predefined slot name in brackets without any options. Now let's have a look at our app again. When checking out, we'll need the user's name and address. So we'll update our dialog to add two new voice commands. The first one will capture the user's name and the second will get the user's location. Here's where we'll use predefined slots. Regardless of the type of slot used, the value captured within the slot is denoted as a special variable, p.slotname.value. You can use this variable in responses or in the script logic. For example, let's follow up this voice command with a confirmation of the coffee ordered. As you can see, here we're using a template string with backticks to let the voice assistant name the captured value. Let's see how these commands work in the debugging chat. Alan has captured all of these pieces of data and identified them. We can now use this data in our conversation. In our voice commands, we have several patterns. For our convenience, we can add item names to the variable and use it in a slot. Here are two arrays with coffee and dessert names. We also have item IDs here, and they will be used a little later when we synchronize voice commands with the app's visuals. We can use the map method to get item names and save them to a string separated with a vertical bar. Look at the new line in the code, console.log. This logs the result to Alan Studio's logs located at the bottom part of the code editor. Let's open logs and see what we get. And we can test our command in the debugging chat. Slots are very powerful and create a robust dialog. As usual, feel free to read more about slots, special slot fields, and values they store in our documentation. Next, we'll go over advanced slot scenarios. Let's talk about advanced usage of slots. When you create a slot, you provide exact variants of what the user will say while giving a command. This works great for single words, but becomes a problem if the slot values are a combination of words. The user might say the words in the wrong order or skip parts of the phrase, and your voice assistant won't understand the command. To address this, we're going to use slots with fuzzy matching. When you enable this option for a slot, you instruct your voice assistant to consider variants of the phrase that are close but aren't 100% match. Let's add an example to see how it works. In our voice command, we have coffee names made of two words. The voice assistant will understand if we order creamy latte, but won't understand if we order latte creamy. To enable fuzzy matching, we'll add the tilde character after the slot name. Now if we try latte creamy, Alan will be able to match it. To ensure the voice assistant responds with the proper verbiage and not, "Here's your latte creamy," we can use labels for slots. A label is a special slot field where you can store descriptions or characteristics. Let's add labels with simple coffee names to each value. Again, we will use the tilde character for that. Now, instead of the slot value, let's play the slot label to the user. Let's test it in the debugging chat. And another great thing about slots is that you can use regular expressions, also known as regex. Regex is helpful in capturing strings with different digit and letter combinations, like IDs, flight or license numbers, and so on. For example, we want Alan to capture the user's ID that may consist of any 3 digits. We will use the following command. We've added an asterisk to the slot name to tell Alan that it contains regex. In the variable with regex, we used an additional backslash. It's an Alan platform requirement that if your regular expression contains a backslash or apostrophe, you should always add a backslash to escape them. Let's try it in the debugging chat. Another example is a flight number, which can be a combination of 2 letters and any number of digits following them. Here, in the first variable, we create a pattern for 2 letters. In the second one, a pattern for any number of digits, and then compose them with the reg variable. Let's test it. Regex is also helpful for an open-end phrase. For example, if you want to capture the user's comment or feedback. In the next command, we are using a greedy regex with the plus character to capture anything the user will say. Let's try it with different phrases. Now, regex captures everything that the user says after my feedback is, and the voice assistant can then play the captured phrase back to the user. Let's hear the user's comment about the order. This is where a greedy regex is helpful. We'll add a new voice command to our script and test the dialog in the debugging chat. Regex is a powerful tool. If you need a hint on how to compose a specific pattern, you can find it here. Now that our dialog has a few commands, let's integrate the Alan voice assistant with our app to see how it works. In this video, we'll cover how to integrate Alan with any app. Click Integrations at the top of Alan Studio. Here you will find all the steps needed to bring Alan's voice to your application. Alan supports lots of platforms, frameworks, and languages, but integration steps are typically the same. First, you get an Alan client SDK and drop it into your application. Depending on the platform, this can be an SDK package, a link to the library, or an NMP package. Next, you add the code for the Alan button to your screen or page. Then, perform additional actions if your platform requires it. Once you compile your app, you'll see the Alan button on top of your UI. Now you can click it and interact with the voice assistant built into your app using the commands from the voice script we've designed. Let's see how it works with our web app. We need the web platform and JavaScript. Here we see the instructions list. We will need to add 2 code snippets to our web page. One, a container for the Alan button that goes to the body section. And 2, the next snippet code goes to the scripts. This code snippet has a link to the Alan platform library, which is the Alan client SDK for web, and the code for the Alan button itself with the project SDK key. The SDK key is unique for every project. It tells Alan to which voice deployment it should connect. Upon refreshing our page, we'll see the Alan button. Let's try some of our voice commands. What can I get here?
You can order a coffee and a dessert.
And get me an Americano.
Here you go.
The integration process is really straightforward and takes a couple of minutes. In the next video, we will see how we can synchronize our voice commands with the app's visuals. In this video, we'll talk about the communications that happen between the script and the app. When we communicate with each other, we not only use our voice, but also the visual context of the environment around us, like body language or where the conversation is happening. We're going to do the same thing, but with our app. First, we'll start with synchronizing voice commands with activities in the app. We recommend always supporting voice commands with visual cues on the page. For example, We can highlight named items on the page or populated fields in the app with information the user provides. To achieve this, we'll send commands from the voice script to the client application, and once the application receives these commands, have it perform the necessary activities. Let's see how this works. Here's our command asking about available snacks and drinks. Let's update to play all the coffee items we have in our coffee array. We will use the loop for it. Now, we'll open our app and see the same items we'd like highlighted as the voice assistant goes over the list. We need to send the highlighted command from the script to the app, and we'll do it with the play function we've learned about before. In the function, we define a JSON object with the command name and the ID of the item card on the page to highlight. Now, we'll do a quick test in the debugging chat. And with the command set, let's address how the client side can handle them. Scroll down to the Allen code button. Notice the onCommand handler here. This handler tells the voice assistant what to do when it gets a command from the voice script. Let's update it. The command invokes the highlight product function we have in the app and passes the item ID we received from the script. You can find the highlight product function below. It adds the highlighted class to the named item and removes this class from its siblings. Time to try it. What coffee do you have?
We have cappuccino, latte, americano.
With commands, you can trigger virtually any activity you need. When communicating with our voice assistant, we can get a coffee. Let's add the selected item to the cart when we name it. To our intent for getting a coffee, we will add a new command that will send the selected coffee name to our app. On the app side, we will update the onCommand handler to invoke the setCoffee function we have in our app. This function adds the selected coffee to the cart and highlights it. Let's see how it works now in the app. Get me a cappuccino.
Here you go.
Let's use another example and populate fields in the app with voice. We'll update the name intent to display the captured value in the name field in the app. First, we will send the name to the app with the add name command. In the app, we'll add another condition. If the command is add name, we need to display the captured name in the name field on the page. Let's try it. My name is Jane.
Thank you, Jane.
Now, take a try populating the other fields in the app. Congrats on completing part 2. In the next part, we'll learn about advanced scripting. In this video, we'll talk about how to organize a multi-branch dialog using context. The definition of context in Allen is similar to the dictionary definition of context. It's the circumstances around a voice command that allows the voice assistant to fully understand what the user needs. In the voice script, a context is a branch or a part of the dialog that is activated in specific circumstances during a conversation flow. Let's dive into the example. Today we'll build a voice assistant for a food ordering app and want our users to follow a few steps. First, the user orders food and adds it to their cart. Then, the user confirms the order to the voice assistant. In this example, adding food to the cart is the only trigger for confirming the order. If the user says, yes, it's correct, or no, I want to change it before step 1, at the beginning of the dialog, it would be meaningless because the user hasn't ordered food yet. That's why we need to wrap confirmation commands in context and pass the dialog branch after food is in the cart. We can create context in the voice script by writing. Then we'll replace the two confirmation commands to the context. Our context has a few commands, but they aren't active, which means that if we try any of them, the voice assistant won't be able to match it. Let's check in the debugging chat. To activate the context and the commands in it, type p.then and pass the context name to this function. We'll place the function inside the voice command that the context will be activated by. This way, our voice assistant will know which point in the conversation a new branch of the dialogue must become available. We'll add a small change here and add another play function to prompt confirmation from the user. Let's try it once again. Once the user is done with this dialog branch, you can deactivate the context. The context can be deactivated in two ways. First, the user can give any command outside the context, or add the resolve function directly to the context. To this, we'll type, now when the user confirms the order or declines it, the voice assistant exits the context automatically. In case you need to activate several contexts at once, you can activate them one from another like that. If the user gives a command outside all active contexts, all of them will be deactivated one by one. Now we'll create a branch dialog with a rigid order of steps. First, the user gets coffee. Next, they'll order a dessert. Then we'll get the delivery details. And finally, the order is confirmed. To achieve it, we'll organize our dialog like this. You can do the same now for your voice assistant. Next up, we'll talk about types of commands you can use with the context. Let's continue talking about context and see what commands we can use in multi-branch dialogues with context. A helpful tidbit for multi-branch dialogues is the no context intent. This will tell your voice assistant what commands users can give at any moment. An example will be asking general questions like, what does this app do? In the last video, we learned that giving a command outside the active context deactivates the context. Take the coffee example. The user chooses a coffee and the order dessert context is activated. Next, the user asks, what does this app do? This command is outside of the context, so the context would be deactivated and all commands in it become unavailable, like getting a dessert. Now let's add the no context parameter to the intent and try it in the debugging chat. With the no context intent, the voice assistant will activate the context and lock the user out of the command. So ordering a dessert is still possible as the next step. Adding the no context parameter to our general command will prevent the user from having to start the conversations over, which is great because no one wants to repeat themselves. No context intents don't affect the dialog flow and don't switch the current context. As a result, the user can give any commands like this at any given time, and it'll still remain in the same context as before. Now we'll talk about fallback functions. For example, imagine the confirmation context is active and the voice assistant is waiting for a specific phrase from a user, yes or no. But instead the user says something unexpected. Your voice assistant can handle this with the fallback function added to the context. Now when the user says something unexpected, the voice assistant will reply with the phrase specified in the fallback function. Let's try it. The user will remain locked in this context, meaning that the voice assistant will continue to prompt the user to give an expected reply. Since the voice assistant is designed to attend to the user's requests, it will confirm the user's answer before taking any action and will unlock the user from the context after the command expected by the voice assistant is given. If you want to transfer $1,000 to an account, we want to make sure that we have all of the correct details before executing the request and moving forward in the conversation. So let's take, for example, a user asks the voice assistant to transfer $1 million to another account. When the voice assistant asks to confirm the amount and the receiving account, but the user is accidentally interrupted and says an unexpected response, our voice assistant will prompt the user to provide a confirmation. Our voice assistant relies on user confirmations to ensure that correct actions will be performed. The fallback function can be added directly to your voice script. With it, you can alter Alan's answers given in the case that the user's command cannot be matched. Let's add several answers and see how they work. Now, in case of an error, Alan will pick one of these phrases at random and reply with it. That's a wrap for special commands. In the next video, we'll talk about Alan's predefined objects. Today, we'll review predefined objects that you can use in Alan's scripts. While writing your voice script, you'll need to share your data and pass it between intent calls, context in the dialogue, or even project scripts, if your project has more than one script. To make your life easier, Alan offers several native objects to store and share data. Let's take a closer look at each one. The first object is project. As you can see from its name, data you store in project is available across the whole project scope. Here's how it works. In our project, we have two scripts. In the first script, we'll define the delivery cost with the project object. Now, if we switch to the second script, we can add a voice command here to ask about the delivery costs, and we won't have to define the cost in the second script again. Let's type it in the debugging chat to test. The next object is user data. This object can store data that will be leveraged during a voice session with the user and store any user-specific data. User data is available from any script and context in your project and between any intent calls. To use it, see how in the first command we capture the user's order with a slot and save it to p.userdata.coffee. We can then add it to the other intent and let Alan play the order to the user. Let's try it in the debugging chat. Next, we have state. State is any kind of a dictionary in which you can store any information you want and pass this information to any context. Let's take the previous example, but this time do it with the context and state. Here, when the user orders a dessert, the confirmation context is activated, and the order is passed to it with the state object. While in the context, the user can ask about the order, and the voice assistant will confirm the entire order. Here's how it looks in the debugging chat. The last predefined object is visual, which is used to send the visual state of your app to the voice script. This will make more sense when we do a deep dive on how Alan and the client app communicate with each other. Let's see how we can use predefined objects for our voice assistant. When confirming the order, we can play the order details to the user, like what coffee and dessert has been chosen, and the delivery details like name, address, and comment. We'll use the user data object for this. First, we'll save the values captured with the slots to the user data object. Next, let's update the confirmation command to play the result to the user. Now it's time to test. We'll complete the task and do the same for your voice assistant. Our dialogue is ready. Up next, we'll talk about Alan's advanced functionalities. Related to slots are their adaptive cousin, dynamic entities. To recap, slots are great at capturing pieces of information from a user's voice interaction, but you can't modify them during a dialogue with the user. In cases you need to update the values while the voice session is running, you would use dynamic entities. Dynamic entities are super helpful if your app gets its data from a database or external source to update its values on a more frequent basis. With the help of dynamic entities, you can create flexible patterns for voice commands, which provide the user with a more personalized conversational experience. Another example is updating the list of values based on what the user says, like adding or removing items to the user's favorites list. Let's have a look and play with the code example. Here we have a predefined list of favorites and two commands. First, the favorites list is initialized with Alan's onCreateUser callback. We will talk about callbacks in the next video. The first command is used to add new items to the list. The second one lets you order the item. Note the syntax here. the list is saved to the user data object. Therefore, we are referring to it as U followed by colon. As you can see, our list includes 3 items. Let's try the second command for something that is not on the list yet. Alan cannot match this command. We will now use the first command to update the favorites list. Now let's try the second command for the apple pie once again. As you can see, Alan has updated the list of options on the fly, and we can use the new option immediately. In your voice script, dynamic entities can be defined at different levels. At the user session level, like in our example, at the project level, if you want the entity to be accessible for all application users, and you can also define it with the visual object if you want to work with the list of values coming from the client app. That's it for today's lesson. Dive deeper into dynamic entities and the scopes of their use in our documentation. Next, we'll talk about Alan's predefined callbacks. In this video, we'll talk about Alan's predefined callbacks and how you can use them in your voice scripts. Every voice project transitions through several states. First, when you save your voice script in the Alan Studio, Alan creates a voice project in the cloud and builds a dialogue model for it. Next, as the user opens up an app and taps on the Alan button, Alan connects the project in the cloud and starts a voice session with the user. Once the dialogue is over and the user closes the app, Alan disconnects from the project. If you need to do some work at a specific moment of the project lifetime, you can use Alan's predefined callbacks. Think of predefined callbacks as a series of events that happen from the project creation till the end of the dialogue with the user. And on any of these events, you can tell Alan what you want to perform. For example, you can initialize data when the project is created in the cloud, or load user-specific data like favorites from your database when a new user dialogue session starts. Here's a list of lifetime callbacks you can use. First, onCreateProject. This callback is invoked when the project is launched in the cloud, and here you can do any data initialization. Next, onCreateUser. This callback is invoked when the user starts a voice session. At this point, you can set user-specific information. Lastly, onCleanUpUser happens when the voice session ends. Here, you can trigger cleanup options if you need them. In addition to these lifetime callbacks, you can also use 2 special callbacks. onEnter is invoked when a context is activated. Here, you can do things that need to be done when a new branch of dialogue is created. And onVisualState is invoked when the visual state is sent from the client app. We'll talk more about the visual state later in this course. Let's look at the Flutter Shrine project as an example of how to use predefined callbacks. Here in the logic script, you can get several ideas on how you can use the onCreateProject callback and what actions can be performed when a real voice project is launched in Alan Cloud. Now, let's go over built-in JavaScript libraries. Alan comes with a few popular JavaScript libraries that you can use while creating voice scripts. These libraries will allow you to easily work with API calls, dates and time, arrays, object strings, and so on. We'll start with API calls. In cases where you send a request to a server to retrieve data and then send it back to Alan, you can make an API call from your voice script. To work with API calls, you could use one of the following clients: Axios, a promise-based HTTP client, and Request, a simplified HTTP request client. Next are libraries working with dates and times. The Alan platform offers 2, Moment Time Zone and Luxon. The third library is a LoDash, which will be helpful when working with the JavaScript objects. Let's take a look at a real example. To enable our users the ability to ask about each menu item's ingredients, we'll query a recipe database at this site, get all the ingredients from it, and play the list back to the user. Here's our command to do it. First, we define a URL for the food API. Using it, we can get information about the cheesecake ingredients. Next goes the API key, and you'll provide your own value here. To repeat this exercise, please note you need your own key for this food API. So feel free to sign up on this site and get it. The ingredients list is empty first. When the user says, "What are the cheesecake ingredients?" We use Axios to make an API call by the URL we have. Notice API before Axios. This lets Alan access the built-in JavaScript library. Here's what happens next. When we make a call to get a response, we save the ingredients to the data variable. We then use the forEach method to retrieve only ingredient names and push them to the ingredients array. Once this is done, the result is played back to the user. So let's try it. Check out our documentation for more examples on how you can use Alan's built-in libraries. In the final part of this video, we'll see how async operations work in Alan scripts. In this video, we'll talk about asynchronous operations in voice scripts. In your voice commands, you can implement any logic, from giving simple replies to doing complicated workflows. If the user wants to get information from their voice assistant, a request is sent to your database or an API call is made to retrieve the necessary data. Since these operations may require longer periods of time to complete, you'll need async operations. Async operations can stop the execution of the voice script until the voice assistant receives the necessary result. Let's apply the async logic to the example from our last video. In the previous video, we queried a database for the ingredients list, and everything was done in the same voice command. Here, the logic is split. We have a function to make an API call and a voice command to call this function. Notice the async and await operators in the intent. They instruct the voice assistant to wait for the function to complete before proceeding. Let's try the command in the debugging chat. Now, if we remove the async await operators from the command, Alan will not wait for the function to complete, and we will never get the ingredients list. Async operations are also helpful if you have context in your voice script and want to get the user's answer before you can move forward. Learn more in our documentation. Now that we've built up the dialogue for our voice assistant, today we'll talk about how to test the conversational flow and debug it. Our first testing tool is the one you're already familiar with, the debugging chat. The debugging chat is great if you need to see how separate voice commands or short conversational flows work. Test your requests using either your voice or by typing it out, and your voice assistant will respond and highlight all of the captured values for clearer insight into what's happening in your script. Our next tool is the flowchart. You can find this at the bottom of the code editor, where there's a panel that shows you how your dialog flow is laid out. Flowchart is especially helpful if your voice script has context. Here's where you can visualize how the dialog goes and when specific branches of the dialog are activated. Another tool you'll use is the test view in Alan Studio, which can convert all requirements for your dialog to test cases and repeatedly run them against new versions of the voice script. Let's check how it works. First, map out your dialog, including all commands and conversational branches you want to follow. Next, click Run to see what branches of the dialog are successfully passed and where the conversation breaks, and then fix the problem branches in your voice script. Going back to the code editor, let's take a closer look at the Alan Studio logs. Located at the bottom of the page, it's a great source of information that reports system messages and voice script errors. If you need to debug your script, you can write the results of the script execution with the console.log function and see the outcome for your variables. Let's see what the logs capture. Along with debugging, you will be using Alan's logs to analyze how your users interact with the voice assistant and improve your dialogues. But that's a topic for a different video. With the voice script ready to go, let's move on to the customization step. Alan provides a set of options to customize your voice assistant so that it fits your app, UI, and brand. Options for customizing your voice assistant are available in the integrations view. Some features are only available on premium plans, but in this video, we're going to cover all potential customization features you can enable. First up, use the speech-to-text panel to provide visual feedback of what voice command is being picked up while the user is speaking. This panel is displayed next to the voice assistant button in your app. Record what your users are saying while they interact with the voice assistant. To listen to the recorded user input, click the Play Audio Intent icon next to the voice interaction in the Allen Logs or Analytics view. Customize the voice assistant's listening readiness. By default, when the voice assistant is ready to listen to the user's input, it plays a special sound, but you can easily disable this. Customize the visual style of the Allen button by setting up your own color scheme and providing custom images for every processing state, and adjust the button size for your app. Change your voice assistant's own voice. Choose from different accents and voice tone, like a traditionally male or female voice. Adjust the microphone timeout field to increase or decrease the amount of idle time before your voice assistant is automatically deactivated. For the iOS and Android platforms, you can additionally configure the following settings. Enable the wake word so that your voice assistant is automatically activated by saying, "Hey Allen." Allow wake word activation even when the voice assistant is not the primary app in use on the device. Available exclusively for iOS and Android platforms, capture screenshots directly from the device in use. This shows you what your users were doing in the app while they were giving the voice commands. All data mentioned will be anonymized, but remember to adhere to your own privacy policies when enabling features. Lastly, choose to show or hide the voice assistant button in your app with one click. All configured features are by default applied to all users. On premium plans, you can customize who experiences which features for different cohorts. The ability to create cohorts is another feature that can make the voice assistant button itself available for a limited group of users. This is helpful for testing newly built voice assistants as you gradually expose the voice assistant to larger audiences. It also customizes the voice assistant experience for different groups of users. For example, you can set up accents for different regions or customize the button appearance. You can create cohorts based on specific locations or other characteristics. Here is how you can set them up. After customizing our voice assistant's features, we're ready to roll it out. In this video, we'll cover how to save different voice script versions and push them to different environments. As you iterate on your voice project, you'll need to keep different versions of your voice script at hand. Allen lets you deploy multiple versions of the voice script to different environments for development, testing, and using it on the production site. Easily save your script version with native tools in Allen Studio, clicking the Save as New Version button at the top of the code editor. We'll call this version 1.0 and click Save. The first version is added to the versions list. Now, if we update our script and click Compare, we'll immediately see the differences between the saved version and the current version we're editing. Select the target environment in the Allen Studio and choose the correct corresponding script version. Let's assume we want to push version 1 to our testing sandbox. If we now navigate to the integration section, we'll see that the SDK key for our project has testing at the end. The SDK key in the app that goes to the testing sandbox must also have testing in it. In a similar way, you can create versions for the development and the production environments. Let's see how our voice command works here. What coffee do you have?
We have cappuccino, latte, americano. What would you like to order?
Now, if we want to push the latest version of the voice script to the testing sandbox, we only need to select it in the versions list for our testing environment. Let's check the same command again. What coffee do you have?
We have cappuccino, latte, americano, espresso. What would you like to order?
Now it offers espresso as well. Up next, we'll implement a multimodal experience for our app. In this video, we'll see what client API methods are used to build a conversational UX with the Allen platform. Up to this point, to define the logic for our voice assistant, we've been mostly working with the voice script. However, with the Allen platform, You can also trigger voice activities from your application by using client API methods available for all supported platforms like web, iOS, Android, Flutter, and so on. You can find detailed information about Alan's client API methods in our documentation. But here's a quick overview of the ones we'll do a deeper dive on in future videos. First, set visual state. With this method, you can send information about the current visual context of your app to the voice script and let Alan respond accordingly. We will see how this method works in the next video. Next, callProjectAPI. This method lets you send any data to the voice script and trigger activities without voice commands. This method will also be reviewed in detail a little later on. Other client API methods include the playText method, which lets you play any text string on the application side. The playCommand method. You've learned how to send commands from the voice script to the application. With the play command, you can execute these commands in your app. The activate method. Activate the Alan button programmatically without having the user tap on the voice assistant button. The opposite method is deactivate, which lets you deactivate the voice assistant button. And finally, the isActive method lets you check the Alan button state. We'll see how some of these methods work together. When our application is launched, the voice assistant will play a greeting and prompt the user on how to start the dialog. We'll open up our app and add a few lines of code to the Alan button block right after the onCommand handler. First, let's cover the onButton state. It's a voice assistant's event listener that lets you check on the state of the Alan button. In this scenario, we're waiting for the online state. Alan should connect to the voice project in the cloud and tell us it's ready. You can read more about the Alan button states in the Alan docs. Once this is done, we will use the activate method to activate the Alan button programmatically and then play the greeting next and a hint using the playText method. Let's see how it works in the app. When we refresh the page, the Alan button will be automatically activated and we can hear Alan's message.
Hey, this is Alan, the voice assistant for a coffee ordering app. Start by saying, "What coffee do you have?"
Alan's client API is a great toolkit for building a multimodal user experience. Coming up next, we'll review two more methods you'll be using a lot of: the set visual state and callProjectAPI. The number one quality of a voice assistant is that it's context aware. Let's talk about what that means. We are building a multimodal app, which means users will be able to control the app with voice, touch, or the mixture of the two modes. To make sure our voice assistant provides relevant responses, it needs information on how the app is currently used, like what page is currently open, which options are enabled, or what images can the user see. To provide the voice assistant with this information, we will use our client API method, setVisualState. As you can tell from its name, setVisualState allows sending the current visual state or the visual context of your app to the voice script. And then, based on the visual information, you can differentiate Alan's responses in the voice script. Examples are always best. So, in our food ordering app, we can provide the user with the ability to ask about the items in our cart. Depending on the cart state, the voice assistant can either list all items added to it or can tell that nothing has been added to the cart yet. We will start with the client side. Open the app and add a new order object to it. Leave it empty at first. Now we'll update the two functions we have, one for getting a coffee and the other for getting a dessert. First, we will update the order object with the coffee or dessert the user wants. Next, we will add the setVisualState method to them. This method takes a JSON object with any content you need. Here's how we'll send our order. Now here's how it all works. When the user makes an order, either with voice or by clicking a card on the page, the voice assistant updates the order object and sends it to the voice script. Now let's add a new voice command to ask about the cart state. First, we will save the past object to a variable called order. The visual state information is saved to a special p.visual object. we will access the order key of it since the object we've sent was named order. Next are two conditions. If the object is empty, the voice assistant will play, "You have not ordered anything." Otherwise, we will play, "You have ordered," and then list all the items in the order. Now, let's see how it works. First, refresh the page and ask, "What's in the cart?"
You have not ordered anything.
Now, let's add something to the cart and ask once again, "What's in the cart?"
You have ordered Americano, apple pie.
This is an example of how you can differentiate responses in a single command. You can also create several commands and use the visual state as a filter for these commands. Read more about this scenario in our documentation. The past visual state can be used for dynamic entities, and you can add the onVisualState callback in your voice script whenever you need it. Again, refer to our documentation for more detail. Next, we'll talk about triggering activities in an app without a voice command with callProjectAPI. The last client API method we will review is callProjectAPI. An important thing about the multimodal UX is that voice should work in sync with other input modalities. So if your users communicate with your app through touch and type, you may want to support their activities with voice. For example, if they make an order using their mouse and keyboard and then click the purchase button in your app, you can confirm the order with voice. To trigger activities in the app without the user invoking a voice command, you can use Alan's callProjectAPI method. Let's see how we can implement this with the order confirmation example. To use Project API, you need to do two things. First, define a new method in the voice script. Next, call this method from your application. We'll start with the voice script. Here you can define a new Project API method like this. Taking a closer look at it, we first type Project API and define the method name. We'll name our method getOrder, but you can give it any name you want. Our method takes 3 parameters. P, Alan's object we've already come across. Parameters are the data we want to send from the application to the voice script, and a callback function we want to invoke. Our method is going to do something simple. Once we get a new order, the voice assistant will confirm it. Let's update our function. We need to call this method when the user clicks the purchase button in the app. Let's add a new sendData function that will be invoked when the button is clicked. In this function, we will activate the voice assistant button programmatically and call our getOrder method. Now, when the user clicks the purchase button, the getOrder method will be called, and the voice assistant will play the response we've set up in the voice script. Time to try it.
Thank you for submitting your order. Your order will be delivered in 10 minutes or less.
Let's take it up a level and send the order details to the voice script. Inside our callProjectAPI method, we can pass any data we need. For example, information about the ordered items and values specified in the name, address, and comment fields. We'll make a few adjustments on the voice script side to let the voice assistant play the order details and now let's test it again.
Thank you for submitting your order. Your order is cappuccino and brownie for Jane delivering to 1234 Main Street. Your comments: soy milk please. Your order will be delivered in 10 minutes or less.
Awesome. In this part of the course, we've learned how to implement a multimodal user experience with Alan. Next, we'll learn about voice analytics and best practices for building a voice assistant. Hi there! The final part of our course is devoted to voice analytics, best practices, and techniques you can use to build a full-fledged in-app voice assistant. First up, voice analytics. After you deploy and launch your voice assistant, you'll want to understand how the user experience is received. To gain insights into users' needs and identify room for enhancements, you can use two tools in Allen Studio. First, Allen Logs. We've already used logs to check the system errors and to see how our script function works. But by enabling and setting up the phrases filter, you can also see all the phrases being said and catch errors in the dialogue. Another tool to leverage are Allen's Analytics. It provides detailed statistics on how your users behave while interacting with the voice assistant, like what phrases they use and what flows they follow, ultimately letting you quickly detect bottlenecks in your dialogue. The Analytics view presents a set of widgets for every voice data slice. Here you can get information about recognized and unrecognized interactions, session and microphone active time, number of users, their location, what platform they've connected through, and so on, and detailed information about dialogues and patterns. Most of these widgets are straightforward, so let's dive into the one that visualizes the user's behavior. Scroll down to the Interactions widget. It shows the whole dialogue transcript for every single customer interacting with the voice assistant. You can filter the transcript by pattern in dialogue, see all errors, and identify the opportunities for improvement in the dialogue. While playing with Allen's logs and analytics, don't forget about the two advanced options we've talked about in the previous videos. You can capture the intent audio and screenshots from mobile devices to make your analytics even more powerful. In our previous video, we talked about how you can deep dive into users' interactions with Allen Analytics. In this video, we'll talk about how to improve your own voice user experience with both the quantitative and the qualitative data. With our analytics platform, we provide you with quantitative data, but you'll need to gather your own qualitative data through user interviews. The goal is to get user insights on what they do or don't like about the experience so far, like how easy it is to find the Allen button, or starting a conversation. This method provides you with instant, actionable recommendations. A common best practice for the qualitative research is to interview 3 to 5 people before and after you design the flow for your voice assistant. We always recommend interviewing unbiased users, but if your pool starts off limited, feel free to ask your friends for their initial thoughts. In our Assets section, you can find 2 documents that will help you with it. 1, a voice UX interview template, and 2, a UX results presentation. In the VUX interview template, you'll see 3 tabs: Hypothesis, Interviewees, and Interview. The first tab, Hypothesis, is where you should put your statements, assumptions, or observations important for your app or business model that need to be tested by the research. A good hypothesis should be 1, precise about what it's measuring, and 2, testable in what you check in this single observation with the one hypothesis. We recommend having a small list of 4 to 5 hypotheses. All of them must be formulated as observations that can be later evaluated as true or false. For example, the first hypothesis on our list is the user finds the Allen button and starts interacting with the voice assistant. If this happens during an interview, the hypothesis is proved right. Otherwise, it's proved wrong. Checking the hypothesis is the focus of our interview. We've prepared a sample list for you and our imaginary food delivery app, so you can make a copy and use it in the future for any other research you will conduct. Next, the Interviewees tab is used for interview coordination. Use it to list the participants in your research, schedule a call with them, and include all the details like information about the participant and demographic or firmographic information that could be a factor in your hypothesis, like age, interviewees' experience in adopting new technologies, or experience in food ordering online. On the final tab, Interview, we have interview questions you'll want to ask. Across the top, we have our list of participants. All the questions and the steps are on the left. Below, we've listed our recommendations, but you can adjust however you find best. Let's go over it in detail. First, we start with a clear and concise introduction that goes over what the goal of the interview is. In the context section, we have 2 to 4 questions related to the research topic and the participant's experience around it. For conducting research on our food ordering app, one of the questions can be, can you tell me the last time you ordered food online? Please describe your experience. The goal is to ask open-ended questions so the participant can provide as much color as possible. In our last step, we'll be testing our hypothesis with the participant. Before you start, make sure to start recording the meeting and have the participant share their screen. Here we have our internal notes with the hypothesis we want to prove. Make sure you don't read these to your participants. Next, read the text of the task you have prepared. Ask the user to perform an action. This is where you'll see your hypothesis proven right or wrong. Each separate task directly corresponds to one hypothesis. Note how the hypothesis, the user finds the button and starts interacting with it, comes with the task, imagine that you want to order a coffee. How would you do it here? Ask the user to think out loud while completing the task so you can observe them acting and listen to their thoughts and put it into your notes. If our participant does find the button and starts interacting with the voice assistant, we put 1 to the column next to them. If not, we put 0. You can then guide the participant by saying, do you see this? Please do that. And then go on to the next task. Repeat the steps above for every task and every hypothesis, make sure to put a 1 or a 0 next to it. Lastly, don't forget to thank them for participating. By the end of the interview, your spreadsheet will look something like this. Once you've interviewed everyone, it's time to move on to the next step and populate the presentation with the data you've obtained. We've created a template, but as usual, feel free to adjust it to your needs and goals. Use your interview sheet to incorporate the result into the deck. The goal of the deck is to have a cumulative view of each hypothesis, so feel free to include quotes from the interviews and hypothesis outcomes and a short description of what happened. On slide 3, list the results for each hypothesis. Green if the hypothesis is proved by over 75% of participants, and red if it is not met. For example, you can see what I have listed here. You can use this presentation as documentation of the changes you've made and why, so that in your next iteration, you can easily talk about your findings and actionable insights with your team. If you have any questions or want to share your findings, our team is here to help and listen. Feel free to email support@allen.app. Looking forward to seeing your projects come to life with voice. Next up, let's talk about best practices for commands design. In this video, let's cover voice UX best practices. The Allen team works closely with teams to create voice scripts and design voice conversational flows. In this video, we'll talk about different UI elements and how to enable voice workflows for your customers to easily control your app. We'll start with lists, groups of similar items combined in a meaningful sequence. The basic operations for working with lists using voice include reading out an item list, scrolling up and down the page with voice, highlighting items in a list, and filtering the list by the user's request. The next UI element is content. This can be a page, a screen, or a view in your app. This is the body or the main part of what the user sees on the screen. You can add voice commands to let the user search for information on the screen, open any attachments, ask for extra features and options that may be related to the content. Next are tasks, which are combinations of content, lists, and forms. While working with tasks, the user can edit them with voice, expand or collapse task views and close them, navigate between tasks, check the task metadata like tags and statuses. In our course, we've covered working with forms to populate fields with voice. Here are some activities you also might want to consider: submitting the form with voice, updating data in the form, and filling out several form fields with a single voice command. An important option is navigation through the app with voice. We recommend that you add voice commands to open specific screens, tabs, and sections in your app. You can also allow the user to search for and pick items from item sets. Another aspect is voice enabling notifications so apps can send push notifications to their users about important events. Along with the visual notification, Allen's voice assistant can also read the text out loud. If your app deals with maps, you can allow the user to zoom in and out with voice and work with a specific map layer just like with a content element. And the last element to discuss is a quiz or questionnaire. Let Alan play questions to the user and notate the answers and navigate to the next or previous question set. Remember to be methodical with the voice commands you set by brainstorming possible variants of what your customers may say. For example, with elements like slot values, compose slot strings using a Google Sheet, Terminal, or JavaScript as in one of our previous videos. In larger teams, this is where your linguist steps in. Or, if you're in a smaller team, this can be done by your product manager or voice UI designer. That's the end of part 6 of our course.